The spanning thrust arch bridge is an elegant engineering solution that connects two shores like a curved arrow. The structure's strength comes from the arch's ability to balance the pressure it exerts on itself. Each stone and steel piece interlocks in harmony with the others. This allows the bridge to support immense loads, while also adding a visual aesthetic to its surroundings. Rising silently over rivers and valleys, these bridges represent a delicate balance between nature and humanity, the convergence of strength and beauty. The earliest examples of arch bridges date back to the Roman era, but the spanning thrust arch approach reinterprets this ancient idea with modern materials. The durability of concrete, the flexibility of steel, and contemporary engineering techniques combine to create a structure that is both strong and aesthetically pleasing. Therefore, these bridges are not only functional, but also possess an architectural signature that complements their surrounding landscape. These silently standing giant structures are proof of how humanity can create solutions not against nature, but in collaboration with it. These bridges, where strength, aesthetics, and engineering dance in harmony, unite the wisdom of the past with the technology of the future. Rock netting installation is one of the most effective methods used to secure mountain roads, tunnel entrances, and steep slopes. The main purpose is to prevent loose rocks or crumbling debris from falling, protecting both vehicle traffic and surrounding areas. In this system, a highly durable steel netting is firmly anchored to the rock surface. The netting's flexible structure absorbs the energy of the falling rock and holds it in place. This way, all types of movement, from small rocks to large boulders, are controlled. The installation process requires considerable care and expertise. First, the slope surface is examined, and risky areas are identified. Then, using steel cables and special anchors, the netting is tensioned according to the rock structure. This way, the netting not only adheres to the surface, it also covers the slope like armor. Workers perform this process by climbing up the mountainside, sometimes several meters high. Steel rebar work is one of the most invisible yet critical stages of modern construction. No matter how strong the concrete appears, what actually holds it together is the framework created by the steel reinforcement, rebars, concealed within. Steel and concrete work together to create a harmony that can withstand both compression and tension, reminiscent of the relationship between bone and muscle. During the construction process, rebars are first cut to size, bent, and connected according to the project plan. These steel meshes, woven with wire ties, are incorporated into every section, from columns and beams to foundation blocks and walls. Workers place the rebars with millimeter precision because even the slightest error can jeopardize the structure's durability years later.
Electrical components such as transformers, switchgear, and energy cables are installed to connect the wind turbine to the grid. These components are necessary to transmit the generated electricity to consumers. Wind farms are often equipped with MONI. Geological investigations are carried out to understand the internal structure of the mountain. This helps determine the methods by which tunnel construction will be carried out. Lighting, electrical installations, and power supplies are installed in. Workers who clean solar panels play a vital role in ensuring the efficiency and reliability of solar energy systems. Their work contributes to the efficient production of clean energy, making renewable energy sources such as solar energy more viable. The overpass built by Razelbeck within the scope of the grouping is 8.60 meters wide and has a total length of 2,400 meters. It consists of 979 parts that were prefabricated on site and assembled with a 600-ton launch beam and then pre-stressed. The Wind-Float Atlantic project is a collaborative effort involving many companies and organizations. Cone cranes and lifting equipment are used in a wide variety of industries to increase efficiency, safety and productivity in material handling and lifting operations. Axpo Limern is a pump storage hydroelectric power plant, meaning it is designed to store and generate electricity using the principle of lifting water. During periods of excess electricity generation, usually during hours of low demand, water is pumped from the lower reservoir to the upper reservoir. When electricity demand is high, water is transferred from the upper reservoir to the lower reservoir through turbines to produce electricity. The Limern Pumped Storage Hydropower Plant Complex, which includes Spo Limern, plays a crucial role in Switzerland's energy mix. It was a massive effort, requiring millions of cubic meters of concrete, tons of steel and thousands of workers. But eventually, the Panama Canal expansion project was completed in 2016 and new locks began to be used. This is a great feat of engineering that has greatly affected world trade and shipping routes.
The production of a giant ship propeller is an incredible process that turns steel into a giant work of art. In the first stage, special molds are prepared and molten metal is melted in giant furnaces. The giant propeller, which has cooled and hardened, is removed from the mold and emerges in its rough shape. Giant grinding arms and robotic systems smooth the surface and perfect the aerodynamic design. Special balance tests are applied so that the propeller can carry huge loads in the seas flawlessly. In the last stage, the connection points to the propeller shaft are opened with the help of giant presses and made ready for assembly. The manufacturing process of giant train wheels is a feat of strength and engineering, where steel blocks undergo an incredible transformation. First, special high-strength steel alloys are melted in huge furnaces at over 1,500 degrees Celsius. This molten metal is poured into special molds to form giant cylindrical steel blocks. But this is just the beginning. The hardened steel blocks are placed under giant presses and crushed under enormous pressure, gradually taking on the familiar train wheel shape. Aircraft wing production is the process of transforming huge aluminum alloys into an engineering marvel with a flawless aerodynamic structure. In the first stage, ultralight and extremely durable special aluminum panels are shaped in giant press machines to create the basic skeleton. This skeleton is manufactured to provide maximum strength so that the aircraft can withstand incredible speeds and harsh weather conditions. Then, high-precision CNC machines come into play, and even the smallest details on the surface of the wing are shaped at the micron level. The production of wind turbine blades allows the conversion of giant composite materials into energy in the sky through an incredible engineering process. In the first stage, lightweight but extremely durable fiberglass and carbon fiber materials are placed in giant molds. After the shaping process is completed, the surface of the blades is processed by machines and the final touches are made to have an aerodynamic structure. Then, each blade is subjected to rigorous tests. Airflow tests are applied at different speeds in wind tunnels and its durability is measured. Rocket engine production is the birth of an engineering marvel that can withstand incredible temperatures, enormous thrust, and extreme pressure. These metal surfaces are strengthened with special coatings that can withstand temperatures of up to 3,000 degrees Celsius. In order to ensure a perfect combustion reaction, liquid oxygen and fuel must be sprayed with micron-level precision. That's why the injectors are made flawless by laser cutting and meticulous testing processes. After testing whether it can withstand extreme thrust and temperatures, the rocket engine is ready to go to the launch site. Hydroelectric turbine production is the birth process of an engineering marvel made of steel that transforms huge water currents into tremendous energy. In the first stage, giant steel blocks with special alloys are melted in foundries and poured into special molds at high temperatures to create their first form. After the cooling process is completed, the steel body is processed in giant milling machines and shaped with millimetric precision. Turbine blades are produced in an aerodynamic structure that can withstand the huge force of water. This is how the giants of the sky are born. First, the body is produced by shaping ultra-durable metal alloys in giant presses. Then, the powerful engine and transmission system consisting of thousands of parts are assembled. The most critical stage is the perfect balance of the giant rotor blades. After the final checks and flight tests are completed, these giant machines are ready to take off. Turbojet engine production begins with melting special alloy metals and shaping them with high precision. Then, giant compressor discs and turbine blades are machined at micron level and assembled. The combustion chamber is prepared to withstand extreme temperatures, and the air passing through the engine reaches thousands of degrees in seconds. Finally, this power machine, taken to the test area, is ready for the sky by producing a tremendous thrust. The production process of giant cranes that lift tons of weight is like the birth of steel giants. First, high-strength steel is shaped in giant presses to produce the main body. Hydraulic systems and engines are assembled with millimeter precision. Mechanical arms are designed to be durable enough to lift heavy loads, and each connection point undergoes special tests. In the final stage, the tower, boom, and counterweight systems are assembled like pieces of a giant puzzle. And here is the result. Giant machines that shape cities and build skyscrapers are ready for duty. This is how the king of mines and giant construction sites is produced. First, heavy-duty steel plates are shaped in giant presses to create the chassis and body. Then, thousands of horsepower engines and huge hydraulic systems are installed. Wheels? Each one is the size of a car. Finally, load-carrying tests and driving checks are performed. With its giant body and incredible carrying capacity, this beast is ready to carry tons of loads.